Hello everyone, this is the last video featuring the computation of a square root of a real number, and basically what we are going to do is just going to fix some of the ideas from the software engineering perspective, clean the code a little bit, and things that we do is basically let's start fixing it by putting appropriate prototypes. What I mean by that is we're going to use prototype functions. So let's copy everything. Well, cut it here, and then we paste all of them after main, and we start creating the prototype for each of them. Let's copy this, let's paste it here, let's copy all this, and then let's paste it here, and then let's copy all this and paste it here, and let's copy all these 4 things and create the prototypes appropriately. So we go up, we paste all the things that we have copied and just put a semicolon to say that these are all prototypes of all the functions that you will see after main or somewhere in this file. So that's one thing that we wanted to do. The second thing that we wanted to do was fix the hard-coded closeness value, which is this. And what we do is basically we just let's fix it here. So the closeness value, we call it epsilon, which is a traditional way to say the traditional way to define the closeness factor. So we put it as double precision, epsilon, 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 and epsilon. So then we add all them to the function. Let's do it here. Epsilon, epsilon, epsilon. So we have placed the epsilons appropriately. Now we want to change this to so we want to change the value of epsilon. So what I'm trying to say is we want to change the closeness, set the closeness value to epsilon. So what we do is we do it like this. We say closeness factor is basically epsilon. We say the closeness factor, where is it, is epsilon, and then we say the closeness factor is epsilon. Now what we do is here we change it to 0.01, we change it here to 0.01, we change it here to 0.01, and we run this code, and let's check if it works. For 5 it works fine as before, so this epsilon is working fine. Then the other thing that we want to do is maybe remove some of the extra curly braces that we have placed for just one line of if else or something. So for example here, let's change it to just this, because if the if else statement has only one statement, takes only one statement, we can just write it without the braces. Now it looks a little clearer. Then epsilon is here, number of guesses is this one, and here let's check here. There are two things, so we don't want to change anything here. That's fine. We remove these few extra spaces. And we should put all of them before. I think it's fine here. And then we go here. We define the number of guesses, lower limit, upper limit must always be 0. We have defined all this here. We remove this extra two braces. Save it, we go up. So far so good. This is return -1 to make the heron consider cases where it cannot find. It will return -1. Although if it doesn't find, it will never actually go here, so let's just remove this. So that's fine too. Let's see. This one works fine, this one works fine. Complete. Okay. Everything seems fine. Let's run it and see if it works. For 5, it is working. Okay, now we want to add something which is called a default value. So in order to create a default value, what it means is we can initially set that the epsilon value by default will be 0.01. 0.01 is equal to 0.01, and not here actually, I made a mistake here. 0.01. So we have set a default value for the epsilon parameter for all these three functions, which means that if we don't provide any value for epsilon in this second argument position, it will by default consider this as the epsilon. So what we can do is check this. Let's run this code. Does it work? With 5, the epsilon is this. Now look at this, watch this. If we remove this 0.01, 0.01, 0.01, and run it, you will see that it gives the same result, because although we are not providing a value for epsilon, we have already set the value of epsilon to be 0.01 by default. And in order to do this default argument thing, you usually have to do it in the prototypes. So you have to set the default value at the prototype. Anything else? So one other thing that we can consider as good programming style is const. We can use a constant value for epsilon. Const int epsilon. Usually constant values are given by given using all capital variable names. So this way what we could do is we can just keep it consistent with all of them and all the three functions that uses epsilon. And now if we run this with 5, it is not working. What did I do wrong? So let's check epsilon. Oh, well, the mistake was epsilon has to be a double, because otherwise if it's an int, it thinks that it converts this into 0 first and then does the computation. So that was my mistake. So let's run it again. Oh, some other file was working, so let's remove that file, close it, and then run it again. Control R, and let's do 5, and it works. Thanks.